So now that we know how to find these infinite limits from graphs and tables of values, we're going to look at how to deal with these things analytically, given a formula. First of all, in that example that I already showed you, we saw that we had those infinite limits as x was approaching 0 from various sides. Notice that if you were to plug in 0 over here, your denominator would equal 0, but your numerator isn't. Remember, we already saw if we have 0 over 0, we have some simplifying to do and then see what happens. But in this case, I have a number over 0. That will always be the case where I get an infinite limit. So the first thing we need to know is these occur when plugging in gives a number that is not 0 over 0. So I'm going to start these problems like I always do by just plugging in to see what happens. If I get a number over 0, then I'm going to follow this method I'm about to show you. To evaluate, first of all, if I have an overall limit, I can't handle that right away. I need to split this into a left-hand limit and a right-hand limit. First thing we're going to do is we're going to split into left and right limits. Again, though, of course, I'm only going to do this if it's not a one-sided limit already. Then what I'm going to do is I'm going to think about this thing numerically. What I mean by that is I'm going to plug in normally to the top, and I'm going to plug in something close to the bottom. And we'll see in a moment how this plugging in will give us everything we need to get our infinities and negative infinities for solutions. Let me show you how to do this. Let's take a look at the limit as x approaches 1 from the left of x squared minus 3x over x minus 1. I'm going to do what we always do first. I'm going to start by plugging in to see what sort of form I'm in. Let's see, I'm going to get 1 minus 3 over 1 minus 1. I've got negative 2 over 0, which is the right form for me to get some sort of infinite limit. So I'm going to use this process over here. And this is actually really important. It's really important that we only use this process when we have a number over 0. More on this later. But if you use this method in other cases, you're going to get very, very wrong answers for those problems. What I'm now going to do is I'm going to go and I'm going to plug in. I'm going to plug in 1 exactly as is to the top. 1 squared minus 3 times 1. I already know that that's going to give me negative 2. On the bottom, I'm going to plug in something close, it says. I want to plug in something close to 1, but because of that minus, it should be a little bit less than 1. 0 is way too far away from 1. I need something much closer, but a little to the left of 1. How about like 0.99999? If you do 0.99999 minus 1, you're going to get negative 0.000001. Go to your calculator and do negative 2 divided by negative 0.000001 and see what happens. Take a moment, go do that. Let's see. Here's my calculator. But when you did that, you should have gotten a pretty big positive number. That answer, though, isn't the limit, because I really shouldn't be plugging in 0.999999. I should be plugging in something even closer to 1, like 0.9999999999999. If that happens, we're going to get negative 2 over a really small number. But a small, what sort of number? A small negative number. When you divide any regular number by a small number, the answers get very, very, very big. In this case, I want to do negative 2 over a small negative number. Well, is my answer going to be infinity or negative infinity? I'm just going to use my regular sign rules. What's a negative over a negative? It's a positive. Your answer, your limit, is going to be infinity. Let's try another one. Let's actually do the exact same problem, but this time let's take the limit as x approaches 1 from the right of x squared minus 3x over x minus 1. I know that when I plug in, I still have 1 minus 3 over 1 minus 1. I have negative 2 over 0. I'm in the right form to be able to use my numerical stuff. So I'm going to go and plug in. I'm going to plug in 1 as is to the top, 1 squared minus 3 times 1. And on the bottom, I need to plug in something just a little bigger than 1, like 1.00001. Up top, 1 minus 3, negative 2. Bottom is a small number. But what sort of a small number? Is it a small positive or a small negative? Yeah, it should be a small positive here, 1.00001 minus 1. That's a small positive number. Well, I know I'm going to get some sort of infinity. A negative divided by a positive gives me a negative, so my answer is negative infinity. I would like to see what you can do with the limit as x approaches negative 3 from the right of x plus 2 over x plus 3. See what you can do with that. Okay, so let's see, plugging in, I'm not going to say equals, plugging in gives me negative 3 plus 2 over negative 3 plus 3. I've got negative 3 over 0. Yep, it's the right form for an infinite limit. So I'm going to get negative 3 plus 2 on the top. And, okay, a little to the right of negative 3. Let's think number line here. If I'm a little to the right of negative 3, that means I'm about here. That's like negative 2.99999. Negative 1 over a small positive. Negative over positive gives me a negative, and I'm going to get negative infinity. Make sure you're still being good with your limit notation. As soon as you plug in, which in this case is my plug in something a little close to the bottom and plug in exactly on the top, I am no longer writing that limit symbol. Limits until we plug in, no limits once we do start plugging in. Okay, a couple more of these. Let's take a look at the limit as x approaches 1 of 2 minus x over x minus 1 squared. Well, plug in, and you're going to get 2 minus 1 over 1 minus 1 squared. That is 1 over 0. The right form for it to be an infinite limit. However, I don't know if I should be plugging in like 1.0000001 or 0.9999999. Which one should I use? We actually need to use both of them. I need to rewrite this problem in terms of two one-sided limits, then evaluate those, and then based on those, get my answer to the overall limit. So I need to split into two limits. I'm going to do the limit as x approaches 1 from the left of 2 minus x over x minus 1 squared. And I'm going to go do the limit as x approaches 1 from the right of 2 minus x over x minus 1 squared. Maybe I'll get you started with the first one, you'll do the second one, and then you'll try to reach a conclusion for this problem. Let's see. So over here, I'm going to plug in 1 to the top, 2 minus 1, and I'm going to plug in a little less than 1, so 0.99999 minus 1 squared. That gives me 1 over, okay, 0.999 minus 1, it's a small number, it's a small negative, which I'm then going to square. Now, if you take a small negative number and square it, multiply it by another, well, by the same, really, small negative number, you get an even smaller number, but is it going to be positive or is it going to be negative? Negative times a negative gives you a positive, so I'm going to get 1 over an even smaller positive number. Well, 1 over a small positive, that's infinity, so that limit is infinity. You go try the next one. I'm going to plug in 1.0001. That gives me 1 over a small positive, which I'll square. That gives me an even smaller number, and a positive times a positive is a positive, so 1 over a small positive, and I'm going to get infinity. So now, what's the overall limit going to be? Well, because both of these agree, we can say that the limit as x approaches 1 of 2 minus x over x minus 1 squared is going to equal infinity. The only reason we can say that is because both of these things agreed. If one was infinity and one was negative infinity, we'd have to say that our answer is does not exist. Okay, a few more. Let's take a look at the limit as x approaches 5 from the left of x minus 3 over x minus 4. Actually, how about you take a moment and see what you can do here. I hope you started off by just plugging in, because we should always just plug in first. 5 minus 3 over 5 minus 4. Oh, wait a minute. Let's see. 2 over 1. We're not getting that form that tells us it's an infinite limit. In fact, we're done with this problem. That answer that I'm getting is my limit. You should not be plugging in 5 to the top and 4.9999999 to the bottom. That's not going to help you. Here we just plugged in, we got 2, we've got our answer. We're only going to be plugging in something close when we get a number over 0. In any other case, we use our other methods that we've already talked about. Let's see what we can do in this one. Let's do the limit as x approaches 4 from the right of x squared minus x minus 12 over x squared minus 8x plus 16. When we start this the way we always should by plugging in, we get 16 minus 4 minus 12 over 16 minus 32 plus 16. This gives us 0 over 0. You know what? Now would be a good time to take a little break and take a look at our flowchart for limits. Are we evaluating a limit as x approaches a number? We're still just approaching a number, so I'm going to go follow that path. Is the function piecewise or absolute value or step? No, I'm going to follow that no path, which then says I plug in. If I get a number over a number or 0 over a number like I got in the previous example, that's my answer. If I get 0 over 0, Well, that tells me I do what we did back in section 1.3. I have some simplifying to do. If I end up with a number over 0, that's when, and the only when, I split into two limits, if necessary, and then I do the numerical stuff. But that's not the case over here. I have 0 over 0, so I need to simplify. And I think the way we're going to simplify this one is by doing some factoring and then canceling. I'm going to get the limit as x approaches 4 from the right of x minus 4 over x plus 3 over x minus 4 times x minus 4. Well, that's nice. Those x minus 4s cancel. And now we're going to get the limit as x approaches 4 from the right of x plus 3 over x minus 4. Going back to that flow chart. I simplified, and now the flow chart takes me back over to here, which says I need to go and plug in and then see which of these three branches I'll then follow. Well, now when we plug in, I'm going to get 4 plus 3 over 4 minus 4. I'm getting 7 over 0, which means I'm going to follow that new branch that we just dealt with for today, the branch that says what happens if I have a number over 0, my infinity things. I already just have a one-sided limit, so I'm going to plug in exactly to the top and plug in something close to the bottom. This is going to give me, and since I'm plugging in no limit symbol anymore, 4 plus 3 over, a little to the right of 4, 4.00001 minus 4. You go finish that off and see what you can get. I'm going to get 7 over a small positive. Positive over a positive gives me a positive, and I'm going to get positive infinity over there. One more of these that I'd like to look at with you. Let's take a look at the limit as x approaches pi from the left of the cotangent of x. I'm not the biggest fan of cotangents. I would rather deal with sines and cosines. So let me start by doing that. I'm going to say that this is the limit as x approaches pi from the left of the cosine of x over the sine of x. Well, I'm going to go and plug in, and we're going to get cosine pi over sine pi. Cosine pi is -1, and sine pi is 0. I'm in the right form to get my infinite limits. Well, I'm going to do the cosine of pi on the top, and I'm going to do the sine of, okay, this isn't great notation, but go with me on this, something a little less than pi on the bottom. I already know the top is -1. I think the easiest way to think about this is to think about the unit circle. Let's see, pi is over here. And I know that the height of something over here would be 0. If you're a little to the left of pi, that means you're going to be a little above the x-axis. You're at a really small height over there. So the sine of something a little to the left of pi is going to be a small positive number. -1 over a small positive is going to give us negative infinity.